Farming 14L homemade tools. Number 14L, real true education, not fake news. This is a Kuhn disc mower, and this rope got tangled around the spindle, and when that happens the belt slip and it can be impossible to get it off. So you have to take the spindle off, and there's the way they're on. They're held on with a nut like that. So we just pause now for a second. Now folks, we'll take a wee look at under the 14 series, and some people have asked me why I put numbers. Each number is meant to be a particular topic, like farming or COVID-19, and for 19 for COVID-19, 14 for farming. It doesn't go exactly like that, but it provides some little guideline anyway. What we're going to look at here is making your own tools and the issue of homemade tools. So it's a bit windy, and it's the 16th of August, and it's turned a bit damp. So the techniques will be used here is the welder and the grinder, welding and grinding. And straight away I have to say about the safety of protecting the eyes with the proper welding mask and the proper clear visor, or good goggles, good protective eye protectors when you're doing grinding. Now the next thing we're going to go on to now is just to look at, just be a few tips might come in useful. All I can say is these have worked with me. We'll have a wee look at the different types of steels without getting too technical. EN1, now the old British system, the old kite mark system was EN. And those are the big, and they're the engineering standard in England for years, but they're nearly all superseded, nearly all replaced now by the American Automobile Institute and engineers in Germany and all over the world. There's about 3 different specifications for steel, and we're not going to go into it here, but they're all closely related to an EN number. Somewhere along the line they come very, very close to an EN number, and they're still used in most places. They still use the EN number in Ireland and in Britain. So you have EN1A. There used to be EN1, but they've modified it a bit, and that's a leaded steel. There's a little bit of lead in the steel. It's a mild steel which is leaded, and it's for use for a lot of machining is needed, like making a cogwheel or something that has very little stress, something that would be in a position that doesn't need a lot of wear or a lot of stress. Forget about it, because it's very difficult to weld. It's very difficult to weld. Don't bother with it. EN1A leaded. It's only for a very fine work. EN1A then is not leaded. If you get it not leaded, and make sure when you're getting it that it's not leaded, it's ordinary low carbon mild steel. And EN1 is the same as EN1A, just very slightly different specification, and it comes in hot rolled and cold rolled, and cold rolled is what's known as bright mild steel, and it's a great material. Hot rolled is very often flat and all that, and you'll see a bit of scale on it where it was hot, and it's good too. It tends to be a wee bit rougher in the grain, and whereas the cold rolled steel, the bright mild steel, tends to be stronger with a bit of hardness in it, and it can be a bit difficult to drill. You'll see the drill starting to give a bit of a spark, but it's good steel. So for all of this anyway, we'd be using the bright mild steel mostly. Now there's EN8, which is a medium carbon steel and is capable of being hardened and tempered. You want to make sure if you're buying it that it's the condition it's in is known. You can run a hacksaw on it or a file. Generally speaking, it comes mild, or it may be hardened and tempered, which should be probably okay too for this. It's a slightly better, more resilient type of steel, and for making certain shafts and things with a lot of stress, it won't wear as quick when it's hardened and tempered. The next steel then is EN19, and it's not very common. You don't see it very common in Ireland and Britain. I don't know why. Now it usually only comes in T. There's there's R, ST, STU I think it is, and S stands for annealed. It's soft. I think that's the way it is. But T is definitely hardened and tempered. And then there's U, which is harder again. You want the T one. Well, you won't get it anyway, only the T one. So if you don't have heat treatment facilities, and most won't, you might probably avoid this. But if there is a bit of it, EN19T, it's good steel. It'll weld, it'll machine. You can use it in a lathe, you can drill it, you can do everything. It's just a wee bit tougher, and it's great impact strength and great resilience. Oh, it's tough stuff, good stuff. I always find it a wee bit heavier to feel, but good tough steel. Like, I mean, nails, if nails were made out of it, you wouldn't bend them too easy. But it's still machinable. That's the point. It's a great steel, not used in a lot of applications in Ireland. I just can't think of anything offhand. And of course, if you're hardening and tempering it, if you have that way of working, it's a good steel for that too. But its next closest relation is EN24, and that's very common. That's used in the axles of it's used in the pins of JCBs and diggers, and for attaching the buckets. And it comes in soft, annealed, hardened, and or tempered. Usually you'll get it soft. So whereas you'll get EN19, which I think is used a lot in axles nowadays as well, and it's used a lot in crankshafts, this EN19. The EN24 is more readily available. It's just a slightly different specification of an alloy steel. It's more readily available, and it comes in hardened, softened, annealed, or hardened and tempered. I'd go all for the soft one. I buy it in the soft, and it's easy machined, and then you can heat treat it. Again, the ordinary farmer's not going to be into that, so please don't turn off thinking I'm going to be getting you heat treated. The next thing is tool steels, and they come in a variety of things. And the head of a billhook is a tool steel, and the head of a sledge is a tool steel, and it can be made into a sharpened bit. And old drill bits were made of it and all that. Again, you won't be using it that much, and if you harden and temper it, it gets brittle. So it's not that important here. Now, car axles and tractor axles, I've made some fantastic components. If you soften this, heat it up and let it cool slowly, I'm not going into that here, it's great stuff. But you can use the centre bit, not the splines at each end, centre bit, and you can use that for what I'm doing here, and it's quite good. However, I have to say that the bit of ordinary bright mild steel is hard to beat. It seems to be the toughest of the whole lot. So again, in any of the things I'm showing you here, eye protection, please wear eye protection. Do not risk the eyes. So one of the things that's very handy, and you can buy them for $9.99 in Lidl's at the moment, is a caliber. Now, I have engineer's calibers and all that, but there's an ordinary caliber, and that'll measure the diameter of a hole. It'll measure a shaft or anything like that, and it'll measure depth. And you just bring it up, clean the jaws, bring it up, press 0, and that gives you a 0. And then when you do that, then it'll measure in metric or inch. It's a fabulous little bit of kit for the money. And if you mind it, and don't leave it parked up, or don't leave it switched on. I think it goes off itself, and it comes in a Grand Wee carrier case. I cannot envisage any handyman that wouldn't have one of them. And it'll measure a drill bit for you. When you go in to buy the drill, it'll tell you if it is right. If it's a 4.5 drill, you want to be sure, just put that on it, it'll tell you. You need good glasses otherwise to read it. The Opel Astra car has a steering rack, and at the end of it there's the 2 ball joints that extend out and go into the track rod end to make the wheels go over and back. And you can't use a socket, because the long extension won't let you use a socket, no matter how long the socket is. And you can't get in ahead with a ring spanner or any other spanner, or even a Stilson, which you would use, because the chassis is in the way. So I was forced to make this fella. Now, this is made on a lathe. So if you went to an engineering shop like Murray Designs, I'm sure they mightn't do it, it's too small. But Morris Moffat might do it if you give him a bit of time and he turn up that to the spec you want. Now, again, you might get a piece of tube and that'll do it. You might get away with it, but I've just shown it to you for the sake of argument. You have these holes here, then you have it reduced here. You have a piece of inch, I think this is 1.25 inches, ordinary mild steel, and 2 holes. And you just shove that up and put the extension, the little driver in there, the wee bit of the track rod end shaft with the thread on it. Shove that up and it just tighten these here, and you can screw it off. So, simple idea, mightn't do for everybody. Here's a homemade thing for doing the brakes on a car. Now, you can buy these, not that expensive. The problem is they come in a big plastic box, and there's about 6 times too much stuff in it. There's for lorries and cars and vans. Generally speaking, I just do the car or the van brakes, and this is adequate. Now again, a lathe was used in the making of this, but I didn't make the threads. I just welded on a nut. I wouldn't expect you to do this. It's just an idea that's what you can do. And this one here then winds it. Some of them need to be wound in. They are on a thread, especially back brakes on some yokes are on they need to be, as well as you push this in, this here has to be wound in, and you can do the two together. Just showing it to you as an idea. I'm not saying you'll probably bother your head with that. Now, again, the next thing is in the use of this, you'll have the 9-inch or the 4-inch angle grinder. Great yoke. Just watch the eyes and watch, it'll burn the clothes and all. It's not, don't use it for a fire hazard, but great machine if you just protect the eyes. Remember, it never goes without the eye protection, ever. Now, the next thing is, here's an example here of a spanner. I needed a spanner in a hurry one public holiday to take off a 46mm nut. It's a brass nut from a pipe fitting, copper pipe fitting, and it was tight. My God, I tried everything, and this is what I came up with. So it's just a piece of 6mm hot drawn steel, 2 pieces of 10mm welded on each side. Well, bring it down using your micrometer to measure this. Get it made a bit bigger than the actual nut you want to open, and then grind down the 2 sides. Weld on one side, having cleaned this off. Weld on one side. Then get this a little bit tight, that the nut's a bit tight, and weld on this one. And then you can grind and file using your eye protection so that you get the exact tight fit. And better all if you have to give it a wee tip. Now I have a bit of work to do on this yet. I'll drill a hole there and I'll cut that bit off. It's too long. But that's an idea there if you're stuck. Now that this is an open end, in effect an open end, you might be able to buy one if you see one. But I buy them, but I lose them. So I never lose these type of ones. So I never lose a spanner I make myself for some reason. I don't know why that is. That's an idea there of what you can make, and you'll put that in the vise, and you'll grind it and file it a bit. You get a good tight fit, and she'll usually open it. So that's very good where you only haven't too much pressure, but it's still an open end, and an open end has a serious drawback because it has only 2 contact points, and if the nut is anywhere weak, it can slip. Now you get these ratchets, and they keep breaking. This one will go one way and it won't go the other, and I haven't the time to be bothered operating on it. Here's another one here. It went when I give it a tip on something. If you try to use them as a hammer or anything like that, they will go. Yeah, they're all right, but just on the right place. You'll often pick them up at Variety Mart and that a bit cheaper. Anyway, here's an example of a spanner that simply broke. I just put I can't remember, was it had a pipe on it, but it broke anyway. There it's there. That's a commercial spanner, drop forged. Looks to be all right. Maybe it's a bit cheap Chinese, I don't know. Anyway, the next thing is then to make a spanner yourself to turn something, and here's an example of a very good design. And this is made out of the inside of the axle of a truck, and most cars are big enough. Most cars shock absorbers. Oh sorry, I said the inside of an axle. The inside of a shock absorber. So you go along to the garage or an old scrapyard and get an old shock absorber. Sometimes they're a bit damaged here, but you'll get them, and just take out the inside out of it and throw the rest away. And this is fabulous stuff. This is great steel. It's chrome plated, and it's the real job. And if you weld it, it gets tougher. It doesn't get worse, it gets tougher. Now it's better off give it a bit of a grind the chrome off it before you weld it. And you see the design here, there's a strap. See that strap? Now the funny thing in this one, I used this inside of the, what do you call it, the shock absorber for this piece here, and when I put the pull on it, it broke. This was looks like 1/2 inch. Yeah, it broke. It rung, and that tends to prove the point. There's nothing to beat bright mild steel for strength. Bright mild steel is nearly better than this stuff, and that's as tough as you'll get. But yet, when the real gorilla torque is put on it, she went. See that there now? Now that's very useful, and I want to dwell with a wee thing with that design in a minute, and they're pretty unique design. Now, the next one then I want to deal with is a bigger one, and if this one for taking off the nuts off tractor wheels and all kinds of things, and then taking off the nut off the Kuhn disc mower, you jam it with wood. You don't put the pressure on the gears inside. You jam the one you're taking off so that it is caught. Do not use the gears and then put the pressure on. Jam this one here jam this one. Jam it, the one you're taking off, and do not put the pressure on the gear. Okay, that's always try and avoid putting pressure on the internal parts. So now, what we're talking here now is this spanner, and this here has this is built up with wood, with wee strips of weld, and then it's ground to the exact size to fit an inch driver. Okay, an inch driver. Now, this end of it here, and I might have to give it a bit of a whack. This end of it here is ground inch. Sorry, I think. Oh, this is 3/4 inch. Yeah, this is 3/4 inch, and this is inch, I think. Yeah. See the way it's done? You just weld it alongside and grind and weld until you get it right and get it fairly good. And this one here, then the very same. And you might want to use something to make sure you get these opposite each other. You know, at the right at 90 degrees. Perhaps a square book or something, and put it up on this would give you a bit of a guide. It doesn't have to be exact, but as you get down nearer to it, you can start to grind away, and then you can use a file and get it finished fairly well. It doesn't have to be exact. Now this is a half-inch drive, and this is the way you get the toughness. This is bright mild steel, which is tough, and then you put this on, and this then will drive this if this is what you have. Now you always use the biggest driver you have. Always use an inch 3/4. The bigger this is, the better. But it depends on what you have, and it all depends on circumstances. Now, so the other thing now I want to mention about this is that the great thing about this type of spanner is that you can put your socket on, right? Whatever it is. If it's, we'll say, for a wheel, or for taking off a wheel nut, and you can build up blocks under this side. Do you see that? You always have to have a few ash blocks around the place, good blocks of wood, about foot diameter, 15 inches, and you can put this on the side. And when you put the pressure on this, you're not trying to do this. Never ever bother or even think about trying to put this on like that and then pull it. It'll pull down. It'll pull down, and it will not work. Now, some of the commercial ones have the closer this distance is here, the better. But I don't know of any other spanner commercially available that does this, and this is a gift. You put that in, you put your blocks on the heat, get it the right size, you have a chainsaw there, and then you can put the pressure, and everything goes into the torque on the nut. Or if you're using the big one, here you have inch, the big strong internal diameter, six-sided inside socket, and everything goes into the nut. That'll make her go. And when I take off the discs of the Kuhn Moore, you have the same problem. And what I very often do is I jam this into the hood underneath, so that it can't, when I pull it, it can't come with me this way. Now, some people will say, "Oh, you can get a spanner. You can get a spanner that'll do all that." But spanners will break, and that's the problem. Here's one here. And this is a reasonably strong one. Broke off. Look. Now that design will get you down fairly near to the nut, in fairness to say. It's better than nothing. But they're breaking. Because there's two. At the end of the day, there's only a very small piece of metal here, and it widens it out and it breaks. See? Right? I've never had any of my own break, except that one I showed you that rung off. But then, with this design, you can grind again, you can go again. You can go again. You could even weld some kind of an extension to it, or some other better job on that. So you get that idea. You have blocks at the other end and pull it in the middle. It's a great job. Now, here's another design. This is for the bung on a Hitachi EX100 digger. The bung comes down like a nut, like that, and there's a pipe coming out of it, and you can't get a socket on. In fact, I think whatever way it's done, it's very hard to get a ring spanner on it. So you can use an open end, but it's not made of good metal. It's kind of like mild soft steel. I don't know what's in it. It'll ring on you very easily. So this is the job here. So this again is the same idea. Measured with the micrometer to I'd say they're 14 or maybe 12, no, I'd say they're 14-inch extensions. Weld it on, make it a bit small, and then grind them and file them out a wee bit till you get them a tight fit that you have to drive it up on it. But the key of this one, and if you have a drill press, it'll be greater. You might have to go to someone to drill this. You drill a hole in here for an 8mm bolt, or a 10, and you get your set of taps, if you have them, like this. There's the set of taps. You'll buy them in Oxy, Ark and Dundalk. You buy them online, and most, it's not hard to get them. Metric is a fairly standard size. Now, so you buy them. You make this hole here big enough to take the whole bolt, and then you thread the other end. Now, if you can't thread, put a nut on it, and that'll do the same thing, right? So when you put that on and you tighten this, this brings the whole lot in tight. And that'll give you unbelievable torque. It's a great design. Again, I know of no commercial spanner that actually tightens on the nut. It's like a Stilson, only a better job. And you make them in any size. I mean, €2, maybe €3, and your time. Now, the other thing then is that a lot of sockets have a weld. You see the way that there is kind of hollow? It goes inwards. That's so it fits on the nut. Real handy. It goes down in the nut. See it there? Now, and here's another one that had the same. And these are great sockets. Now, when you're buying a socket, always go for the 6 inside. Don't go for the 12. You know, this is a hexagon. Don't go for the 12-bit because they don't grip the nut as well. If you look at the 6-sided one here, you see that it fits exactly onto the. See that? Fits in perfectly. That's what you want. It's very rarely that you need the 12 side where you only can get a certain amount of a turn on it. So what we're saying is here, I do put these in the lathe and cover the bed so you don't damage the lathe, and I grind them off with angle grinder, again using goggles to protect the eyes. But you could do this in a vise. In other words, you can grind that off in a vise, or you could put it on an extension, on a driver, and get someone to twist it around while you're grinding it, you know, or even try and get it fairly good. But the flatter you get it, the better. And you can keep looking at it, and as it's going round, it'll come round, or you can nearly do it by eye. But the key is you're not losing this wee bit. The contact edges on this are about 3mm above on the nut, so there's a part of the nut is not getting torque at all. If you look on this nut here, there's a big heap of things here that doesn't do any good. It's not till you get to here, see that you have a contact, and you don't want to be using that contact, wasting it with the socket. You need a socket that will go down the whole way on that and pull it to the very, very butt, and you clean the nut off, scrape it with a screwdriver, get it good and clean, and then drive on your socket hard, and then you come along and put on your spanners. If you're stuck for a bar to give it a good torque, the top link of a tractor, I'll tell you one thing, that'll give it a queer pull. And but you can always have a few piece of hollow bar about that length. I keep giving them away. People look for them off me, and I'm always making them. I'm always without one, but hollow bar is essential. When you're making this kind of a spanner here too, don't make this too long, because you'll be using something like this here on it to make it go. Sorry, just a second. Oh, yeah, just phone rang there. So that idea there, don't make it too long. Now you can see again the strap. See the strap on this? See this? The piece of metal and the strap driven round. And just to show you how this is done here, you build up this with a bit of weld on the shaft and get the corners on it, and then you grind it down to suit. Okay, Bright Mile steel is as good as any. Good steel. I wouldn't be going too much to getting better steel. It usually won't let you down. And with that, now on the 16th of August, folks, it's brightened up a little bit again here now. There was a bit of rain, and I'm trying to make about 15 bales of hay. We'll see how that goes. And that's everything. I think I've told you everything there. I emphasize, please, I had one there somewhere about eye protection. Yeah, this is the most important thing. Most important thing. Please, don't do it. Don't take risks. It's molten steel comes off the angle grinder. Once you do that, once you realise that the welding glass and the angle grinder go hand in hand with the protective eyes for them, then you're away in a hack. You have very, very handy tools. And a drill press, if I didn't mention, is a handy thing to have too. A very handy thing, a bench drill. Get one about 1/2 inch. I'm not sure if I mentioned that. So I think I've covered everything there. People might say, oh, why don't you go and buy a spanner? I tell you one thing. Jenny Mac, you won't get one better than that. You won't get one better than that. And I'd say that cost me maybe €5. €5. Bit of electricity and a bit of time. That's it, folks. I hope that's useful to you. You'll never be idle when you're handy. So with that, we'll let you go. And thanks very much. Give me a thumbs up if you want, or a thumbs down, or spread it around. Might be some use to somebody. And we'll let you go at that. Okay, thank you.